Next we have the graph of the cotangent function. So if we're going to look at y equals the cotangent of x, and this will be very similar to the tangent function. If we go to our calculator, once again realize we do not have a cotangent key, so that means we're going to have to actually type in y equals, for cotangent we could do 1 over the tangent of x. This is using your reciprocal identity, so 1 over tangent is equal to the cotangent. So we would type in, go to y equals, and once again make sure your calculator is in radian mode. So we would type in 1 divided by the tangent of x, and again I always like to go to zoom 7, which is zoom trig. And if you'll notice a little bit of difference here with the cotangent, notice as we go from left to right, the graph over here now is going down from left to right, whereas for the tangent, notice it was going up from left to right. So, and also the cotangent function here, as this comes down, it's crossing through this point here, whereas the tangent, remember, it went up and crossed through the origin. So there's a little bit of difference here. So if we copy this and move this over, we have our cotangent. So again, we kind of see some similarities. If we mark off here from 0 to 2 pi, we have pi over 2, and then we would have pi, and this point would be 3 pi over 2. And once again, just like before with the tangent function, notice we still have some vertical asymptotes, but the vertical asymptotes have moved compared to the tangent function, because if we look at the cotangent, remember for the cotangent here, y equals the cotangent of x, that's equal to cosine over sine. So again, looking at the unit circle as we go around, we have our key points here that we want to look at. So we would have 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. So now what we're looking at, the vertical asymptotes, if we take the sine of an angle that is going to give us our y value, if we notice here at 0, and then over here at pi, our y coordinates are 0. So therefore we have a vertical asymptote because we would have cosine over 0, and again if the sine function goes to 0, we have division by 0, which makes the cotangent function undefined. So that's where we're again having these vertical asymptotes through our cotangent function here. And if you remember, if we looked at one period, we're going from, in this case, we can look at going from 0 to pi, and that's going to give us a period of 1 pi. So the period of your cotangent function is similar to our tangent in fact that it's going to start to repeat after a period of 1 pi. And of course we can see that the graph here, if we looked, again notice this graph is going kind of down like this. You almost kind of think of it like the tangent, but recall the tangent function, let me see if I can kind of sketch this on here. The tangent function went like this. It would start here, if we recall, and it went up this way. Let's see, it would kind of go down like this. So that would be, if you think here in this purple line, that would be what our tangent function looked like. So you can kind of see the similarities, and actually we'll talk about what we can do here to see if this cotangent function will look like our tangent function, but we'll look at that in a minute. So the tangent function, if we were thinking here, went from negative pi over 2, remember we had this was negative pi over 2, and went to a positive pi over 2, whereas if we think of the cotangent, it's starting here going from 0 to pi. Now keep in mind though, this is just the cotangent of x without any kind of phase shift or change in the period whatsoever. This is just kind of your standard graph of what happens with the cotangent function. So just like before with the tangent function, we can think of this as y equals a cotangent bx minus c plus d. And again, a was kind of our amplitude, but in this case we're not going to really have an amplitude. But if we want to look at kind of our, well, first of all, we'll think of the period, just like we did before. We're going to take pi divided by the coefficient, which is our b value. So to calculate the period, we're just going to take this pi divided by b. And if we want to look at the start of a period, we would take the inside of the parentheses, the bx minus c, and this time we're going to set it equal to, if we look up here where this one starts, we're going to set it equal to 0. And if we want to look at the end of that particular period, we would take the bx minus c and set it equal to 1 pi. And of course we would solve each of those for x, and that would give us a start and end point for one complete period. Now let me look at the graph here. In fact, let me actually copy this over first. If we go to the graph, I'll make another copy, and this is our cotangent. So let me paste the cotangent function here. So let's keep in mind this is y equals the cotangent of x, okay? And now let's go back, and I want to pull up the tangent function, and I'm going to actually graph this here under y2 so we can kind of see what the similarities or difference here would be with the two functions. So if we simply look at the top one is our cotangent with the 1 over tangent. So if I type in the tangent of x now, and notice here comes the tangent function. It gets a little confusing with having the cotangent there. So I'm going to actually go back into y equals, and I'm going to clear out the cotangent. So now we can look at just the tangent function one more time. And I'll copy this over so we can look at some of the similarities and the differences. So here, this is the graph of our tangent function. And what I want you to notice is if we look at particularly here, notice that for the cotangent, and I'll kind of just focus on this one period so it's a little less to look at. So here's our one period here. Notice that where this point crosses right here on the x-axis, okay, whereas over here for the tangent, if we're looking at kind of this period, it crosses the x-axis at the origin, whereas this one is crossing the x-axis here, which would be at pi over 2. Okay, and over here, this is pi over 2, this is negative pi over 2, and we're going from basically 0. If we think of this here, we have a vertical asymptote at 0, and we have a vertical asymptote here at pi, okay? And notice over here we have vertical asymptotes we're at pi over 2 and negative pi over 2. So if we look closely, compare the vertical asymptote over here with the cotangent to where it crosses the x-axis over here on the tangent. We have a vertical asymptote here at 0 for the tangent, That's where it crosses, at 0, it crosses the x-axis. For the cotangent, we have a vertical asymptote at pi. On the tangent, over here at pi, the graph crosses the x-axis. So wherever the cotangent has a vertical asymptote, the tangent is having an x-intercept. And then vice versa. If we look over here at the cotangent, wherever the cotangent crosses here the x-axis, the tangent is going to have a vertical asymptote. So pi over 2 on the cotangent, right over here, we have an x-intercept, but on the tangent at pi over 2, we have a vertical asymptote. Okay, so you're going to find that to be the case for the cotangent and tangent. Now, if you look at the graph again, the cotangent we think of starting here kind of at the top left and going down, whereas the tangent starts at the bottom and curves up. And I want to see if you can pause the video, and I want to see if you can go to your calculator and come up with an equation. We have the graph of y equals tangent x, which is this graph over here on the right hand side. But I want to see if you can, on the calculator, type in an equation using cotangent so that the graph looks just like the tangent function. Okay, so if you want to pause the video and see if you can come up with that. All right, so hopefully you're able to come up with the graph. If not, we're going to look at that now. So if we notice, it looks like we have a reflection with the x-axis. So in other words, if I was to take this, the line over here in blue, if we were to reflect this in the x-axis, the graph then would look similar. If I was to take the reflection of this graph here in blue, the reflection then would look like this. So the question is, how do we get this particular reflection here? Well, that means we need to put a negative. Okay, in order to get the reflection, we're going to put a negative in front of the cotangent function. Okay, so remember, if we put a negative in front, that's giving us the reflection, just like we look back in the sine function and cosine function. And if we notice here, the pi over 2 is on the x-axis, where for the tangent over here, we have the pi over 2. We're looking at this point and this point, the origin and at pi over 2. So there, the graph has been shifted. So we need to move this point here on the tangent function, okay, or I guess think of it as a cotangent rather. We need to move this point. So here we have the orange line. We now need to move it over here to the left. So now that it would be located here. Well, remember, that's what's inside the parentheses, and that would be the x plus pi over 2. Because remember, if we set this equal, that would give us a negative pi over 2. So let's see if we look at the graph of negative cotangent x plus pi over 2. So first of all, we have, here's our tangent. Okay, we have the tangent function here. And I want to look at typing in the cotangent. So let me go ahead and put the tangent in as y1. Now remember, in order to put this into the calculator, we're going to have to type in negative 1 divided by the tangent of x plus pi over 2. So if we go and do that on the calculator, we would have, whoops, again, make sure when you type in the negative, use the negative here at the bottom. Don't use the subtraction key like I started to. So we would have negative 1 divided by the tangent of x plus pi over 2. And remember, we have the plus because it's going to be the opposite direction. So now, so that we can see that this is the same, I want to move to the front of y2. So move the cursor here to the front of y2. And remember, if we keep hitting enter about 3 or 4 times, we get to where you have this open circle. So that way, when it draws the tangent, we'll see it, but when it goes to graph this negative cotangent function we typed in for y2, it's going to trace it with an open circle. So let's see if these are actually the same graph. So here's our tangent, and we know it's going here crossing through the origin. And now it's graphing the cotangent that we put in, and notice it's tracing right over top of the tangent function. So what we've done here is we actually have the exact same graph as the tangent, but we used our cotangent function. And the reason that worked is because we put the negative sign here in front to cause the reflection, okay? And then the pi over 2, we added the pi over 2, which moved the graph pi over 2 to the left. So therefore, the tangent function and this function turned out to be the exact same graph. So the reason I point this out is because if you're trying to match up the graph, you don't want to necessarily fall into the trap of saying, oh, well, if the graph starts at the bottom and goes up, it has to be the tangent function. Well, it's possible that it is represented with a cotangent function. All right, so there's the graph of our cotangent. Once again, it has the period of 1 pi, just like the tangent. So be careful when you're looking at these two functions as compared to your sine, cosine, secant, and cosecant, where the standard period was equal to 2 pi, because here cotangent and tangent start out with only having a period of 1 pi.